Okay, in this video, we are looking at types of numbers. It's a really nice graphic to help us understand how numbers are defined and differentiated a little bit. So let's go to the circle on the left. Actually, all these circles. If you go to the innermost circle, we have these things called natural numbers. Natural numbers are your counting numbers. If I say count to 10, you're going to go 1, 2, 3, 4, 5. You start with 1, you don't start with 0, and it's just all the positive numbers with no decimals. So natural numbers are your counting numbers. Now, your whole numbers, see how the natural numbers are all inside the whole number circle? That's because 1, 2, 3, they're natural numbers, but they also are whole numbers. So what's the difference? Why does a whole number get its own category when it has almost all the same numbers? Really, it just comes down to this one little addition right there. Whole numbers include a 0. So if we're talking natural numbers, you start 1, 2, 3, blah, blah, blah. When you're talking whole numbers, you start with 0, and then you continue to count your positive numbers. Okay, integers, our next bigger set here. Whoops, there's a rectangle for you that I did not mean to do. Okay, so integers, natural numbers are integers, whole numbers are integers. Integers are all of your natural numbers and whole numbers, so 0, 1, 2, 3, and all of the negative ones. So you can see we've got a -5, a -2. So if you were to count through the negative numbers without decimals, you would have integers. Square root of 49 is up here because the value of square root of 49 is 7. 7 is an integer. So you have some integers, the negative ones, that are not whole numbers. A negative number is not a whole number, and it's not a natural number. But natural numbers 1, 2, 3 are whole numbers, and they are integers. Kind of cool, huh? All right, now we have rational numbers. We talked about that in our first video with our vocab. Rational number is a number that can be written as a fraction. It is terminating decimals and repeating decimals. Those decimals can be written as fractions as well. So you have these fractions: 2/3, 7/8, 3/4. -2 is a rational number as well, because we could write that as -4/2. And then you've got your terminating decimal, your repeating decimal. Those have fractional values as well. Rational numbers are part of the large set of real numbers. So rational numbers is a subset of real numbers, using some of that terminology again. Then we have a smaller little circle over here, irrational numbers. There are no subsets of irrational numbers, just those numbers that cannot be written as a fraction. The decimals continue on forever. They do not repeat, they do not terminate. So pi, our most famous one, I think square root of 10 we put in the video, square root of 2, square root of 3, a lot of your square roots, if it doesn't square root perfectly, it's going to be an irrational number. Whatever this is, 1.243, blah, 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 but the dot, dot, dot indicates it will continue forever. Are irrational numbers also real numbers? Yes. Remember, real numbers are all of your rational numbers and your irrational numbers. Basically, you guys are going to be working with real numbers probably until you get to Algebra 2, and then you learn about our friendly imaginary numbers. But you don't have to worry about anything along those lines for a while. If it's a number that you know and you can think of in your head, it's a real number.